Hello and welcome everyone to our breakout session on deploying the F5 and NGINX portfolio with SUSE Rancher. My name is Alan Cheon, Senior Alliances Manager for our Community and Alliances team, and I'm also joined by my good friends and colleagues, Dylan and Mark.
Good afternoon, folks. My name is Mark Dittmer. I'm a Senior Product Manager for BIG-IP Kubernetes Ingress, and we're going to talk a little bit about F5 BIG-IP Container Ingress Services and how it relates and how we deploy it together with the NGINX Ingress controller.
And my name is Dylan Turnbull. I'm a solutions architect with our Community and Alliances group at NGINX, and I help manage the partnership with SUSE and Rancher with Alan.
So for today's agenda, we'll be talking through some of the challenges when running Kubernetes in production, how F5 and NGINX can help, and our integrations and our partnership. So with that said, when we talk to our open source community and customers about some of the main challenges they face when deploying Kubernetes in production, three common things are always top of mind: visibility and insight, security, and scalability. As we polled our customers in our open source community to understand the different trends and challenges when they are pushing Kubernetes into production, 70% of the organizations we talked to will run Kubernetes in production by 2023. 94% of those folks experienced some sort of security incident as it relates to Kubernetes in container environments, and 44% delayed or halted containerized app deployments into production because of those reasons. But when we're talking about challenges with running Kubernetes in production, we understand and we know that many organizations are along their journey in a different way. Some organizations are more so beginners and trying to figure out how Kubernetes fits into their architecture and their application stacks. Other folks are more on the expert end of things, where they have the right resources in-house and that expertise to be able to roll their own Kubernetes. But regardless of where you are in your Kubernetes journey, Rancher and F5 and NGINX can help. For Kubernetes beginners that don't have the know-how to roll their own Kubernetes, Rancher provides a very slick, easy to use management plane, as well as a GUI that allows you to instrument and manage all of those Kubernetes workloads regardless of where they're being deployed. When it comes to intermediate Kubernetes users, and those folks are looking to start pushing those workloads into production, they're looking for more advanced routing capabilities, more visibility, more telemetry, and also a production-grade enterprise-ready ingress solution with built-in security and visibility and supportability. And of course, as you've become a Kubernetes expert, scalability is top of mind as well as security. So making sure that you have the right ingress solution to route traffic between those pods while still securing them at that pod level, and providing an end-to-end supported solution across the entire application stack. So let's take a look at today's architecture. As we've talked to customers in the open source community, the number of tools that customers and organizations are using to build out their application stacks and deliver these business critical apps have really become cumbersome. As you can tell on this slide, the number of tools that organizations are using has created quite the tool sprawl, and the management of this tooling has become extremely cumbersome for a lot of the developers and architects and NetOps folks that are managing these tools that are being deployed by the different teams. So how can F5 and NGINX and Rancher help? We help by allowing you to simplify that robust, complex architecture with a complementary set of tools from Rancher, NGINX, and F5, where we allow our customers and organizations to be able to simplify the number of tools that are being deployed across their stack for the different use cases that they have, where a combination of F5, NGINX, and Rancher makes it that much easier for organizations to be able to manage legacy apps, deploy new greenfield apps in Kubernetes or microservices with consistent tooling across all these different environments. But we also know that DevOps and NetOps folks in organizations have different responsibilities as well as preferences. When it comes to DevOps folks and their responsibilities, they're primarily responsible for delivering and making sure they have uptime in those business critical applications and shipping as many features as quickly as they can. Versus for SecOps and NetSecOps folks, the responsibility is maintaining and managing the broad platform that's being used to deliver a lot of these multiple apps. From a KPI standpoint, innovation and agility is what's important to DevOps, making sure that they can move as quickly and ship code as quickly as possible without breaking anything, while the KPIs for NetSecOps folks are typically around predictability and security and making sure there's 100% uptime for those apps themselves. When it comes to technologies, DevOps folks really focus and lean in on layer 7 and above, anything that's application centric, and anything below layer 7 or layer 4 and below is magic, typically what the NetSecOps folks have to manage. But for NetSecOps folks, the entire stack is what's important, and security is top of mind. When it comes to form factors, DevOps teams really like using software, particularly packaged in containers or Linux packages, giving them the agility and the ability to move as quickly as possible and to ship code. Whereas for NetSecOps folks, having to manage data centers and on-prem appliances, as well as some of these new software tools that these DevOps and application teams are also using and leveraging. When it comes to interface, many DevOps and application teams prefer to work in an automatable, API-driven CLI, whereas a lot of NetSecOps folks are used to scriptable CLI or GUIs, as well as APIs to make the management of these tooling a lot easier. And of course, we can't forget about security. Whether you're DevOps or whether you're a part of the NetSecOps teams, security is top of mind, especially when we're talking about end-to-end security. Making sure that you're securing the edge all the way down to the actual Kubernetes pods and making sure that you have that extra layer of security at each hop. So with that, how does F5, NGINX, and BIG-IP work together to help our customers when deploying Kubernetes? Mark, I'll turn things over to you.
Excellent. Thank you so much. So this concept of F5 simplifying Kubernetes ingress, what we've done is we've built an architecture, and as you can see the architecture here, but what's really interesting is there's actually a solution that is actually packaged, and a solution where what we believe addresses this modern app delivery at scale. One thing that's really important about delivering this, if you want to call it modern application architecture, is resolving some of those persona challenges. So Alan talked a little bit about the differences between traditional NetOps, network administration, or if you want to call it, there's some new definitions where we define this as maybe infrastructure providers. The infrastructure providers are really responsible for the administration of the F5 BIG-IP. And this is your traditional F5 BIG-IP, whether it's hardware or software, whether it's running on-prem or running in the public cloud. Traditionally, that is maintained and operated by your NetOps persona or your NetOps groups. What we're seeing is that once we enter or once we start working in this architecture where we are ingressing traffic to Kubernetes, what we're starting to see now is a combination of multiple personas. And so one of the main key factors for simplifying NGINX and BIG-IP is really to deliver a solution that helps solve this challenge. And so that's what we define as the F5 ingress link solution. And so if you think about it, this F5 ingress link solution, what it really does is provide maybe a single interface that offers both the best of what BIG-IP and NGINX can foster together, while collaborating. I think that's the biggest one, is collaborating with those different groups. So collaborating between the infrastructure providers, which is your BIG-IP administrators, your cluster operators. So your cluster operators is the operator or the operators within your Kubernetes cluster. So think of maybe your Kubernetes engineer. Those are the maybe a development kind of network Kubernetes engineer that is responsible for creation or deployment of CIS, as well as the deployment of maybe the NGINX ingress controller. So those cluster operators are kind of maybe a little bit between NetOps and maybe a little bit between your application developers, but they're really responsible for scaling the NGINX ingress controller, making sure that CIS is available and CIS can communicate with BIG-IP. So that's really it's interesting. It's providing a single interface that can collaborate with infrastructure providers, cluster operators, as well as providing this platform for the application developers. And so that when the application developers are creating their apps or scaling their apps, the service is available for them, working with these different persona groups. What's also really key about Ingress Link is making sure that we align priorities with minimizing the conflict, right? Minimizing the conflict between the teams while enabling this multi-tenancy or this multi-tenant architecture within Kubernetes. So we talked about these three personas: the infrastructure provider, the cluster operator, the application developer. Once this environment is built, the application developer can continue creating his or her applications without having to rely potentially on other parts of the organization necessarily, because those pieces are kind of in play together or already available. So application developer can create his or her app, and it would be ingressed by the NGINX ingress controller, which the ingress controller would be able to work with CIS to provide that external availability into the cluster. And so that's kind of what's key. So the other thing that's also really important here about Ingress Link is that Ingress Link is going to save time when it comes to the initial deployment and reduce errors with declarative deployments by simplifying the configuration. And so what does that mean? You'll notice there that there is a Ingress Link resource. And think of the Ingress Link resource as a very minimized configuration that is applied to BIG-IP. So what CIS does is CIS is watching the Kubernetes API specifically for the NGINX ingress controllers, and really only those NGINX ingress controllers. Everything else CIS doesn't naturally need to watch. So any application pod, any application service, CIS is not watching or looking at those specific APIs. That's all the responsibility of the NGINX ingress controller itself. So what's actually kind of nice is that if an app developer scales up or scales down an application pod, the HTTP routing is really handled by the NGINX ingress controller. What CIS really does here is auto-scale your NGINX ingress controller's pods. So for example, in this case, if we have, let's say 1 or 5, CIS will monitor the 1 to 5 NGINX ingress controller pods. And if you scale that up or scale that down, what CIS will do is automate the BIG-IP. So tell the BIG-IP that I see we've gone from maybe 5 pods to maybe 7 pods of the NGINX ingress controller, and CIS will automate the BIG-IP, and BIG-IP's pool members will be incremented. So what CIS is doing is really monitoring the NGINX ingress controller and making sure that if there's any auto scaling going on, BIG-IP is automated automatically. What CIS is also doing is providing a public IP for the BIG-IP's virtual IP address. So BIG-IP has a public IP, and that public IP is an FQDN that ingresses all traffic directly to the NGINX ingress controller. So in this instance, you must think this as maybe a 2-tier architecture. And so with this 2-tier architecture, what BIG-IP can do is BIG-IP can use additional services today, and potentially maybe those services are like, for example, WAF services or DDoS, or maybe some firewalling services that can firewall or secure traffic from outside the cluster into the cluster. So that's really what BIG-IP is doing. It's routing traffic from the outside into the cluster and handing that traffic off to the NGINX ingress controller which would then be routed to the correct pod based on its specific HTTP routing characteristics or requirements. It could be path-based, it could be header-based, et cetera, et cetera. That's configuration of the NGINX ingress controller. And so what CIS will do is CIS will work with and communicate with the NGINX ingress controller, create that ingress link resource, which is a CRD, and the CRD would then get created by the cluster administrator. Once the CRD is created, CIS will then pick it up and automate the BIG-IP using a common API. Once BIG-IP has that CRD, what will happen is a virtual server will get created. It will have a public IP address. It will have all the associated policies and profiles that are associated with this specific service. And BIG-IP will then forward all traffic to its pool members, which would be the NGINX ingress controller. So this is a very elegant way of managing traffic into the Kubernetes cluster. And then when it comes to the different personas, what makes this so elegant is the different groups can potentially manage and look at the different pieces. So the NetOps or the infrastructure provider can actually look at the virtual server, can potentially do some statistics on how much traffic is coming into the cluster, or if there's any type of like WAF security enabled, then the infrastructure provider can actually determine if there's any mitigation that needs to happen. So for example, if anything's getting blocked or if anything is getting through, but potentially being logged, then maybe some mitigation can happen at that point. And that would potentially secure the cluster for anything that's really not allowed into the cluster or is potentially maybe vulnerable or doesn't actually get through the signatures. So that really talks about why this architecture is really beneficial. So I want to just reemphasize, Ingress Link is integration between BIG-IP and NGINX technologies. The Ingress Link is really built for customers for this modern app that are utilizing both BIG-IP and CIS. So to simplify your Kubernetes ingress, the use of both F5 BIG-IP and NGINX, really to provide that elegant control plane, the fostering of the different personas while minimizing any conflict and enabling multi-tenancy with reducing errors. And so I think that's ultimately really key about why you want to also look at an architecture like this as well. The other item that is actually really interesting is you can also utilize an additional service on BIG-IP, which is utilizing BIG-IP DNS. So if you want to, Alan talked about once you start getting into like more of the expert mode of using something like SUSE, if you want to actually create multiple clusters or you are creating multiple locations, what Ingress Link can also do now is set or create a wide IP. So what a wide IP is doing is basically allowing you to create a public IP per location that is then pushed up to the DNS layer to provide maybe some load balancing services across clusters, right? So for example, you could have two clusters. You'll have one wide IP, which is basically one FQDN. And within those clusters, you'll have location 1, location 2, or cluster 1, cluster 2. This is a great way for potentially moving traffic around, a great way for site availability. If you wanted to maybe upgrade one cluster, then you could actually physically manipulate the algorithm in the Ingress Link resource to move some traffic around. So that is what a lot of organizations are doing now. They've got their Kubernetes clusters, their multiple Rancher implementations, and now they want to potentially load balance between the clusters. And so that's where the Ingress Link with external DNS really comes into play. What BIG-IP DNS will do will monitor the NGINX ingress controller, as well as maybe some of the applications within Kubernetes to make sure those applications are up and can actually service traffic. If those applications fail, then the wide IP can be removed, and therefore the traffic would then get sent to an active cluster. So there's a little bit more about that. But if you look at this overall architecture, it's potentially maybe a two-tier architecture where you've got big IP ingressing traffic into Kubernetes. You've got NGINX ingress controller that is handling all the HTTP routing and kind of how the different personas kind of match in here. So that's really what I wanted to do, to talk about how we leverage both NGINX and BIG-IP together to provide a better solution, an easier solution that really focuses on the different personas.
Awesome. Thanks so much for breaking that down for us, Mark. So now that we talked a little bit about how NGINX and BIG-IP work together for Kubernetes, let's now talk about how F5 and NGINX can help secure SUSE Rancher deployments. So as Mark was talking about, with CIS and Ingress Link now available between BIG-IP and NGINX Ingress Controller, it's giving customers and organizations the ability to manage both. The network admins or the folks that manage the BIG-IPs now have a play as well as an integration to help those application developers and DevOps folks that are deploying Kubernetes, that are focused on shipping features and shipping code and building apps, while ensuring that they still have that level of security that infrastructure providers expect, while providing that scalability and production readiness. Is there anything else you guys wanted to add here?
So like we talked about in the previous architecture, the Ingress Link resource, we're able to define an existing WAF bot, maybe DNS policy. So what that means is on BIG-IP, there can already be a WAF policy that is actually there to potentially secure traffic coming in to the Kubernetes cluster. So what that would basically mean is that any traffic that's coming into the Kubernetes cluster would basically go through a list of signatures, and anything that doesn't match those associated signatures would get blackholed or removed, or potentially get rerouted, or maybe there are some other options as well that the security administrator would want to set up. So those are common signatures for maybe OF's top 10 types of attacks. So any type of cross-site scripting, any type of SQL query injection, et cetera, that's just 2 of those top 10 would get mitigated before it even gets into the Kubernetes cluster. And that would happen on the BIG-IP itself. And then potentially logging would happen as well. So that enablement of the security profile would be created by the cluster administrator when he or she creates that Ingress Link resource. And there's a capability in there to actually say, refer or reference to this policy. And within these policies, I want you to apply these policies on the BIG-IP. And that could be a WAF policy. That could be a DOS policy. And that could be maybe L4 DOS, or it could be L7 behavioral DOS. Those are different types of levels of policies that you can associate, as well as potentially maybe some access policies as well, where you could be saying only allow access to the virtual IP. Anything that comes into BIG-IP would just not get forwarded to Kubernetes if it's not addressed to the BIG-IP itself. So that means that F5 BIG-IP is providing secure services for protecting Rancher. And what's really important, and I think maybe Alan, you want to address this, is that it's potentially different level of security. You've got ingress security, which is maybe OS top 10, right? We shouldn't ingress any traffic that matches any of those signatures, or anything that's doing a direct denial of service. Then maybe potentially bot defense comes in that from that perspective, and as well as maybe some firewalling where we shouldn't be communicating directly with pods, with the nodes, right? Nothing should be talking directly to the nodes itself. We only communicate with the public IP address that is in the Ingress Link resource, that is either provided by IPAM or provided within the virtual server itself. Anything else should potentially be denied. And that level of firewalling at the network layer or a little bit at the security layer can happen on BIG-IP. But once traffic gets into the cluster, that's a different level of security, right? Potentially pod to pod or node to node level of security is already inside the cluster, right? And that's potentially what Alan can address next. So what BIG-IP is doing is it's addressing the security needs of traffic coming into the cluster, but once the traffic is inside the cluster, really BIG-IP is out of the data path at that point.
Mark, that's exactly right. And that's a great segue to the next slide. So we talked about how NGINX and BIG-IP work together. And then we talked about how to secure SUSE Rancher deployments with F5 and NGINX technologies. Now let's drill down and actually talk about the Kubernetes pods and the east-west traffic that Mark was talking about. As many folks here may know, the Rancher platform actually ships with the community-built NGINX ingress controller. There isn't a WAF that's readily available. And as customers are pushing more and more Kubernetes workloads into production, as Mark mentioned, security has been top of mind, making sure that they have the ability to mitigate any vulnerabilities or CVEs at that pod level, even though they have best security practices implemented outside of the Kubernetes workloads. So with that, what is the NGINX? What's the value of the NGINX ingress controller and app protect WAF for SUSE Rancher? As I mentioned before, the Rancher platform ships with the community NGINX ingress, which we participate in that community and help contribute as much as possible. But as many folks know, with open source projects and community managed projects, there is some inherent risk when it comes to security, as well as production readiness and some of the enterprise grade features that customers are looking for. So with that, what are some of the key benefits of deploying the NGINX ingress controller that we maintain and manage along with our app protect WAF with SUSE Rancher and RKE2? First and foremost, it's our development philosophy. NGINX as an open source project didn't come this far of a way with over 450 million websites globally running NGINX without our development philosophy in mind. It's always been our top priority for our ingress controller to deliver long-term stability and consistency. So we make every possible effort to avoid changes in behavior between releases, particularly anything that breaks backward compatibility. Secondly, it's continual production readiness. So NGINX provides commercial support for every release of our ingress controller. So every release is built and maintained to a supportable production standard. You also benefit from the enterprise grade focus equally, whether you're using NGINX open source or plus. Thirdly, it's around our integrated code base. So NGINX's ingress controller uses 100% pure NGINX or NGINX Plus instance for load balancing, applying best practice configuration using NGINX capabilities alone. It is also natively built in C and does not rely on any third-party modules or Lua code, which the community ingress does rely on, which inherently opens up customers and organizations to some security risk when it comes to CVEs. Fourth, it's around security. So we don't assemble our ingress controller, as I mentioned before, with lots of third-party repos. We develop and maintain NGINX open source and NGINX Plus and the ingress controller software ourselves with the help and contributions of the community themselves. Fifth, it's really around secure cloud native containerized apps. So now that we've been able to build and take the best of breed F5 WAF and app protect and build it from scratch from the ground up for NGINX, now customers have that peace of mind of adding an additional security layer or WAF policies, including JSON schema validations on the actual ingress resource or ingress controller themselves. And then, of course, as customers look to support and manage business critical applications and have their NetOps folks and DevOps folks and application teams focus more so on maintaining and building out the applications themselves and shipping code and building out new features, being able to rely on SUSE Rancher as well as F5 for a fully supported platform. Making sure that you can pick up the phone and call us or SUSE Rancher anytime you have any questions about configuration files or the way that your platform can be supported and deployed. So with that, as I mentioned before, the Rancher platform ships with the community-built NGINX ingress controller. And in fact, there are actually 3 versions of the NGINX ingress controller that many organizations are not aware of. The first one being the community version, as I mentioned, that's maintained and built by the Kubernetes community that we participate and contribute to. And then there are 2 other NGINX ingress controllers that are maintained by us. The first ones are NGINX open source based ingress controller that's natively compiled in C and does not use any third-party modules such as OpenResty or Lua. And then of course, our commercial version in NGINX Plus, which provides some enterprise capabilities, some analytics and metrics, as well as support. So with that, Dylan, can you tell us a little bit about the differences between the community version of the NGINX ingress versus the ingress controllers that we maintain?
Yeah, sure. So the initial community edition, which I think anybody who's used the Rancher Manager before and deployed a K3S or a K8S, RKE1 or an RKE2 cluster, that's the version that you get by default. In the latest version of the Rancher Manager, you can deselect that and tell it, or you can tell it using a manifest to not deploy that as a controller, as the ingress controller. And as you can see, most of the items here in blue are represented by the community. And just to kind of roll through this list a little bit, the footprint of the community, because it's not a natively compiled C code based solution, and it's using OpenResty, it's just by default going to be larger in footprint. So as you can see, roughly about 3 times the size of the natively compiled C version. In addition to that, when you're using a high-level programming language, in almost all cases, you're going to have some latency between when how you're communicating with ostensibly the underlying hardware layer, which is what we're trying to get through these languages too. So because you're going through Resty, then you're going through natively compiled C, and then ultimately to the actual underlying hardware platform, you're just by default going to get slower performance. As you can see here, there's you're gonna experience timeouts with the community edition, which you won't run into with the NGINX Plus edition, because everything with the Plus edition is dynamically reconfigured as part of how the solution works. Timeouts, this is just a off-the-cuff metric. The number of timeouts that we might see from the community edition, and that is a near zero number when it comes to the Plus version. And I think most importantly is the CVE portion of the puzzle, because everything is kind of built in a layered fashion where it starts with our code base and then kind of builds out from our OSS edition to Plus to the community edition. Adjusting CVEs happens in a really quick time frame, because once that CVE is reported, we'll begin to fix that in the native code base initially. And then once that fix has been authored, tested, and regression tested, it's then made available to everyone else in the known universe that utilizes NGINX as a core technology. And then they have to go through many of the same processes to implement the code, test it, regression test it, and so on and so forth. So what you end up with is a natural delay. And I say natural because this is something that you're just going to find with any core technology, where the underlying core technology gets updated first, and then it disseminates out from there and gets addressed. And in every layer, you still have to go through the testing and the regression testing to be able to produce a solution that is, hopefully as bug-free as possible when it's complete and made available.
Awesome. Thanks, Dylan. So we talked a little bit about the differences between the 3 different NGINX ingress controllers that are available. Now let's shift gears and talk a little bit about what the primary differences of NGINX open source and Plus is, and some of the key reasons why our customers choose to deploy NGINX Plus over the open source version when they're ready for production environments. First and foremost, it's really around live monitoring and being able to access over 100 different metrics that aren't available in open source. Being able to detect and resolve failures faster, implementing a circuit breaker pattern with active health checks, As Dylan mentioned, reconfiguring with zero restarts anytime you want to make a change to your NGINX configurations. Always thoroughly testing new features and deployments by making the A and B testing feature available, and being able to rely on our support team anytime you have any challenges with your NGINX open source or plus deployments. And then when it comes to security and compliance, it's being able to secure the edge. The combination of F5, NGINX, and SUSE Rancher now gives customers the confidence in being able to have an end-to-end secure solution, regardless of where you're deploying Kubernetes. Being able to centralize authentication and authorization, and making sure that you have the right folks that are trying to access the apps. Being able to implement end-to-end encryption, as I mentioned, with F5 and NGINX from the edge all the way down to the actual pod level. Getting timely and proactive patch notifications, as Dylan had mentioned about CVEs. And then, of course, as FIPS compliance is becoming more important, ensuring that NGINX Plus, along with SUSE Rancher, is giving you a FIPS compliant Kubernetes deployment. So with that, for any folks that joined our session that wants to look at deploying NGINX Ingress Controller, NGINX App Protect, and NGINX Service Mesh, and F5 Container Ingress Services on the Rancher Apps and Marketplace, you can do so by leveraging the Helm charts that are available and highlighted in yellow. And again, F5 Container Ingress Services is currently in the works, and we should have that available in the next coming weeks. So with that, thank you so much again for joining our session. We hope you enjoy the rest of your SUSECON experience, and we'll see you soon. Thank you.